Okay, welcome everyone. Now we are here and we will solve these all problems. For this, first of all, here in LHS in A, tan 45 plus theta equals sec 2 theta plus tan 2 theta. Okay, how to solve it? So let us take LHS. Here LHS is equal to tan 45 degree plus theta. Tan 45 degree plus theta. Okay, so we know tan A plus B equals, here tan A plus B equals tan A plus tan B divided by 1 minus tan A into tan B. So we can write it as tan A, that is tan 45 degree, plus tan B, tan A plus tan B, so tan theta upon 1 minus tan A into tan B, that is tan 45 degree into tan theta. No? And now we all know that tan 45 degree is equal to 1. So we can write 1 plus tan theta, 1 plus tan theta upon 1 minus tan theta, 1 minus tan theta. But here the problem is that we have to obtain how much? We have to obtain sec 2 theta plus tan 2 theta. And we know sec 2 theta is nothing, just cos 2 theta. No, 1 by cos 2 theta. And tan 2 theta, the formula for tan 2 theta is here, tan theta 2 tan A upon 1 minus tan A square. So we have to be very careful that what will be tan 2A. So tan 2A means 2 tan A upon 1 minus tan A square. And if we multiply both numerator and denominator by 1 plus tan A, 1 plus tan theta, then 1 plus tan theta and 1 plus tan theta, then what we will obtain? We will obtain 1 minus tan A square theta, which is the denominator for tan 2A. No? Okay. So the upper one will be 1 plus tan theta whole square. So we can write 1 plus tan theta whole square, that is 1 plus 2 tan A, 2 tan A. So 2 tan theta plus tan square theta, and the denominator is 1 minus tan square theta. 1 minus tan square theta. Okay. Again, can we get the required result? No. So what we will do? First, let's write this 1 plus tan square theta and 2 plus tan theta together. So we know that tan 2 theta equals 2 tan theta upon 1 minus tan square theta. So how we will obtain? So that's the thing that we have to understand. So what we will do? We will apply some tricks for that. What we will do? Let's write 1 plus tan square theta at one side and then plus 2 tan theta alone. Okay. Assume that we have written 1 plus tan theta, 1 plus tan square theta at our side or as a single combinedly, and 2 tan theta as a separate, and the denominator is 1 minus tan square theta, so we will write 1 minus tan square theta. Okay, again rationalize. Again what we will do? We will multiply this numerator and denominator by 1 plus tan square theta, 1 plus tan square theta and 1 plus tan square theta. Okay, so what we will obtain now? You have to think that can we write this as, let me write once. So first let's write 1 minus tan square theta into 1 plus tan square theta, 1 plus tan square theta, and we will write 1 plus tan theta, 1 plus tan theta together, 1 plus tan theta, tan square theta together. So we write 1 plus tan square theta and multiply this 1 plus tan square theta with this expression. So 1 plus tan square theta. Okay, but we have another expression that is 2 tan theta. Again here 2 tan theta is multiplied by 1 plus tan square theta. So we can write this one as 1 plus tan square theta. Okay, and now separate. We can write this one as a separate in the form of a by b. Okay, so how we will write? We will write it as in this form. Suppose we have a fraction that is a by a plus c by b. So we can easily write it as a by b plus c by b. In the same way, we are going to write this expression. So this fraction. So we can write 1 plus tan square theta into 1 plus tan square theta divided by how much? 1 minus tan square theta into 1 plus tan. So 1 minus tan square theta into what? 1 plus tan square theta. 1 plus tan square theta. Okay, and in the same way, we will write 2 tan theta into 1 plus tan square theta upon same thing, a into c, that is a into b into b, or we can say b into c. Sorry, we will write 1 minus tan square theta into 1 plus tan square. So we can again write here 1 minus tan square theta into 1 plus tan square theta. And now what we will do? Here 1 plus tan square theta and 1 plus tan square theta is cancelled out. Again 1 plus tan square theta, 1 plus tan square theta is cancelled out. So what will be remaining? So the remaining portion will be 1 plus tan square theta upon 1 minus tan square theta, 1 minus tan square theta. No, plus 2 tan theta upon 2 tan theta upon 1 minus tan square theta. Okay, so we know cos 2 theta, cos 2a equals how much? Cos 2a in terms of tan. So cos 2a equals 1 minus tan square a upon 1 plus tan square a. So we can write this one as 1 upon 1 minus tan square theta divided by 1 plus tan square theta, no? And then plus 2 tan theta upon 1 minus tan square theta is 2 tan theta. Here tan 2a equals 2 tan theta divided by 1 minus tan square theta. So we can write it as tan 2 theta, no? Tan 2 theta. And this is, again we write 1 by 1 minus tan square theta is cos 2 theta, no? Cos 2 theta plus tan 2 theta. So here 1 by cos 2 theta is sec 2 theta. Sec 2 theta plus tan 2 theta. So if you, so RHS is proved. So while proving this LHS, using LHS to RHS, it seems very difficult, because first of all you have to think that you have to apply this one, that is 1 plus tan theta upon 1 minus tan theta, and the result is here. And then again you have to rationalize. So multiplying the numerator and denominator by 1 plus tan square theta. So you have to think of tricks 2 times. But if you solve it using this RHS, or you prove LHS using RHS, then it will be very easy. So after proving this from LHS, let's prove using RHS. So it will be very easy. So here RHS is, so here RHS is sec 2 theta plus tan 2 theta, no? Tan 2 theta. And this sec 2 theta means 1 by how much? 1 by cos 2 theta. Cos 2 theta plus tan 2 theta means 2 tan theta upon how much? 1 minus tan square theta. And this cos 2 theta means, this cos 2 theta means how much? This cos 2 theta means again here how much? 1 upon 1 minus tan square theta upon 1 plus tan square theta. So 1 minus tan square theta upon 1 plus tan square theta plus 2 tan theta upon 1 minus tan square theta. So after that you can understand how can we solve it. Okay, so we can write 1 plus tan square theta upon 1 minus tan square theta plus 2 tan theta upon 1 minus tan square theta. So here it can be written as 1 minus tan square theta, and this one is 1 plus tan square theta plus 2 tan theta. So this one is, the upper one is 1 plus tan theta whole square. So we can write 1 plus tan theta whole square upon 1 minus tan square theta, no? So this can be written as, the numerator can be written as 1 plus tan theta into 1 plus tan theta, and the denominator can be written as 1 plus tan theta into 1 minus 1 plus tan theta into 1 minus tan theta. Now you can cancel out 1 plus 1 plus tan theta into and 1 plus tan theta. So the remaining is 1 plus tan theta upon 1 minus tan theta. So here we know tan 45 is how much? Tan 45 is 1. So instead of 1 we will write tan 45 degree plus tan theta upon 1 minus, and here 1 into tan theta. So instead of 1 we will write tan 45 again here into tan theta. So we can prove this one as tan A plus B. So it is going to be tan 45 degree plus theta. In this way, and this is LHS. So using both RHS and LHS, we have proved this first identity, that is tan 45 degree plus theta is equal to sec 2 theta plus tan 2 theta. But it seems very quite easy than proving using LHS than proving using RHS. So you can use any of them, but for LHS, while using LHS you have to predict, or you have to think of the result. But if you have sec 2 theta plus tan 2 theta, it's very sufficient, and you can easily simplify and get the required result. Okay, so let's see, that is B. So 1 minus sine 2a equals 2 sine square minus 45 degree. So how we will obtain 1 minus sine 2a equals 2 sine square 45 degree minus a. And again this one is 2 cos square 45 degree B and C. 2 cos square 45 degree minus theta equals 1 plus sin 2 theta. So you must have to understand one thing, that is here 1 minus sin 2. So using LHS or RHS you can prove using any of them. So here LHS is 1 minus sin 2a, 1 minus sin 2. Okay, so we have to prove this one, 2 sin square 45 degree minus. So how we will prove? Do you have any idea? So what we can do, that we can just simply change this sign into sin 2. We don't have any formula regarding sin square with respect to sin 2a, because we have only sin 2a equals 2 sin a into cos a. So do you have any idea how to change this sign into cos? So we know sin how much? Sin 90 degree minus theta. This one is cos theta. Okay, so and also cos 90 minus theta. 90 degree minus theta is equal to sin theta. We know that if there is sin 90 minus theta, which is going to be cos theta, and if there is cos 90 minus theta, which is going to be sin theta. We all know why, because this one is 90 degree, and using this cast rule, CAST, 90 minus theta falls in this first quadrant and all are positive, so the sign is positive, and the rotation is 1 into 90, as it is here 1, so sign changes into cos, that is theta. So sin 90 minus theta is cos theta. Similarly, cos 90 minus theta is sin theta. So we have to apply the same concept. So this sin 2a can be written as 1 minus cos 2, or we can write cos 90 minus 2a. No? Can we write or not? We can easily write this one as cos 90 minus 2a. Why? Because this cos 90 minus 2a is sin 2a. We don't have to change this sin 2a into cos 2a. But we can write sin 2a equals cos 90 minus theta, no? Okay. So we can write this one. Again, what we will do? We will take common 2. So we take common 2. So we can write 45 minus 2. Okay, up to here, I think it is very clear. As here it is given 1 minus sin 2a. So first we convert this sin 2a into sign in form of cos. So we can easily write this 2a in the form of, that is cos 90 minus 2a. And again from this 90 degree and 2a we take common. So this 90 minus 2a can be written as 42 into 45 degree minus a. No? Okay. So 1 minus cos 2 into 45 degree minus a. No? So how we will do? How we will move further? And the result is 2 sin square 45 degree minus a. So let us see here. The result is 2 sin square. So we will apply which formula? This formula. If the LHS is here, cos 2a equals 1 minus 2 sin square a, and from this what we can write? 2 sin square a, 2 sin square a is equal to 1 minus cos 2a, 1 minus cos 2a. No? Using this relation, what we can do? From this we can write 2 sin square a equals 1 minus cos 2a, and here what you can see, that 1 minus cos 2 into a, and here a is 45 degree minus a. So we can easily write 2 into sin square. No? And instead of here it is 2a, so we write only a, and a is 45 degree minus a. So we write 45 degree minus a. So what we have to prove, we have already proved here. So this is going to be okay. So using this RHS, can you prove LHS? Yes. Just reverse it. So first write 2 sin square 45 degree minus a. No? Here 2 sine square 45 degree minus a. If we we use this RHS, then using RHS if you have to prove LHS, then what we will do? First of all, there is given 2 sine square 45 degree minus a, and using this relation we can write 1 minus cos 2a. So we will write 1 minus cos 2 into 45 degree minus a, and then what we will do? We will multiply this 45 minus a with 2, so we are going to get 1 minus cos 90 minus 2a, and then this cos 90 minus 2a is going to be sin 2a. In this way we can prove this. Okay, so I have proved using this LHS, and you have also proved and make you understand how to prove using RHS. There is nothing, just reverse. Okay, using LHS you get RHS, and just reverse the step, you will get LHS. The third one is 2 cos square 45 degree minus theta into 1 plus sin theta. So how we will do? Again here, this one is given, here LHS, is how much? 2 cos square 45 degree minus theta, no? So 2 cos square 45 degree minus theta. Again here, 2 cos square theta. So we consider this all as theta, and it is going to be a. So 2 cos square a can be written as 1 plus cos 2a. So we write 1 plus cos 2 into a. So 2 into a is going to be 45 degree minus theta, no? And now we can write 1 plus cos 2a. And what we have to prove? 1 plus sin 2 theta. So 1 plus cos, just multiply this 45 minus theta with the 2. So it is going to be 90 degree minus theta. And this cos 90 minus theta is going to be 1 plus sin theta. And you know how this cos 90 minus theta is going to be sin theta. We have already talked about it earlier in the problem of while solving this problem B, no? Okay, so if you have to prove this 2 cos square 45 minus theta using this RHS, you can just reverse the steps and you can easily prove this one. Okay, so it is how much? And this is 2 theta, no? This is 2 theta, so it is 1 plus sin 2 theta. So here RHS is good. Okay, so how you will prove this D number? Here it is cos 45 degree minus a minus sin square 45 degree minus. So I think you can prove it yourself, because this is nothing, just cos square a minus sin square a, and cos square minus sin square is how much? How much it is? How much? Cos square minus sin square is cos 2a. Cos 2a. And this cos 2a can be written as how much? Cos 2a. Cos 2a can be written as cos, how much can we can write this one? So as cos square a minus sin square a is cos 2a. But here in this case, what, instead of a there is 45 degree minus a. So here it is 45 degree minus a, no? So on multiplying we will get 90 degree minus a, no? Cos 90 degree minus a, and you all know that this one is nothing, cos 90 degree minus 2a, no? So cos 90 degree minus 2a, and this is going to be sin 2a, no? Okay, I have also proved this one, D. Just use this one, this formula, just relate this D number, that LHS, with this cos square a minus sin square a. So here a is nothing, 45 minus a. Again there is a is 45 minus a. So we can write cos square a, instead of a there is 45 minus a. And we all know that cos square a minus sin square a is cos 2a. So we write cos 2, instead of a we write 45. 45 minus 8, no? So it is going to be cos 90 degree minus, minus 2a, and it is sine 2. Okay, in this way we have proved this one. So it is RHS. Okay, how you will prove this? Tan a plus 45 degree minus tan a minus 45 degree is equal to 2 into 1 plus tan square a upon 1 minus tan square. How you will prove? Do you have any idea? I think this one is very simple. Why? Because you have to apply the formula for tan a plus tan b, and this one is minus tan a minus tan b. So for this, here LHS is how much? Here LHS is tan a plus b, and here b is 45 degree. So tan a plus 45 degree minus tan a minus 45. No. So what we will write it here? Tan a plus tan b upon 1 minus tan a into tan minus tan a minus, as it is here negative, so we write tan a minus tan 45 upon 1 plus tan a into tan 45 degree. Okay, so we all know that tan 45 is 1, so it can be easily written as tan a plus 1, no, upon 1 minus tan a minus tan a minus 1 upon 1 plus tan a. Okay, so what we have obtained here, the numerator, this denominator is 1 minus tan a, and this one is 1 plus tan a. So just take the LCM. So what we will get here? 1 minus tan a into 1 plus tan a, and this 1 plus tan a and this 1 plus tan a. So it is going to be 1 plus tan a whole square minus 1 plus tan a, 1 plus tan a. So it is going to be, so we can write 1 plus, so we can write this one as minus tan a minus 1 into 1 minus tan a. No, so one is tan a minus 1, another is 1 minus tan. So if you take the common minus, then this one is going to be plus, so the expression will be 1 minus tan a. So just take the common, common 1 from this one. So how you will do? If there is minus tan a minus 1, no, so if you take minus common, so minus 1 minus tan a, no, isn't it? And here minus minus is going to be plus, so it is 1 minus 10. So we can easily write plus, no. So let's write in the next step, that is we also expand this one. So 2 tan a plus tan a square, okay, and this one is plus how much? 1 minus tan a whole square upon 1 minus tan a square, no. So now we have also to expand this one, 1 minus tan a whole square. So how you will expand it? The same way, that is 1 minus tan square. So it is going to be, I think I will write this one. No, why to write two times the same thing? So what we will do, we will write 1 minus 2 tan a, 2 tan a, and this one is plus tan square a. So this one is 2 tan a and this one is minus 2 tan a. So it is going to be cancelled out. So what will be remaining here? 1 plus 1, that is 2. So it is 2 plus 2 tan square a upon 1 minus tan square a. No? So I'm taking common. That's 2. We will write 1 plus tan square a upon 1 minus tan square a. So we have proved this one, that is RHS. So proving this one, this LHS using RHS is going to be tough, because we have to think these all, these all stuffs we have to think. But if you use this LHS and prove RHS, then there is nothing, just simplification. No, just you have to simplify, and finally you are going to get the result. So it's very easy. Okay, how we will prove this f? So to prove this f, what we will do, just take LHS. No, here LHS is 1 plus tan square 45 degree minus theta upon 1 minus tan square 45 degree minus theta. And we all know we have to prove cosec 2 theta, but we know the formula in respect of this tan, for sine it is how much? 2 tan a upon 1 minus tan square a, 2 tan a upon 1 minus tan square a. 2 tan a upon 1 minus tan square. But in case of cos, we have the formula 1 minus tan square a upon 1 plus tan square a. So we can easily write it as 1 upon how much? 1 minus tan square 45 degree minus theta upon 1 plus tan square 45 degree minus theta. And this 1 minus tan square theta upon 1 plus tan square theta can be written as how much? Cos 2 theta. So we can write 1 upon cos 2 into a, and a is here again 45 degree minus theta. No? Okay. And we can write this cos 2 45 degree minus theta as how much? 1 upon cos 90 degree minus 2 theta. No? And this cos 90 minus theta is how much? 1 by how much? Sin 2 theta. No? And we all know cosec 2 theta is 1 by sin 2 theta. So it is cosec 2 theta. That is RHS. Hence we have proved this RHS. In this way we have proved all of these identities. And if you haven't understood all this, I have tried to make you understand in very easy and simple way, and using very simple steps, and also using the basic concepts. Okay. And if you haven't understood, it's my advice to watch this video 1 or 2 times, then it will be easier for you to understand. Now we have to prove these all. So how we will prove these all? Cos theta equals 1 by 2 into a plus 1 by a. Then we have to prove cos 2 theta equals 1 by 2 a square plus 1 by a square. So how we will prove these all? So how we will prove these all? So how we will prove these all? We don't have to do anything. Just the value of cos theta is given. No? The value of here, the value of cos theta is given. And cos 2 theta, we have to prove this cos 2 theta equals 1 by 2. So here you can see that the formula for cos 2 theta is how much? 2 cos square a minus 1. And if cos theta is given, why to worry much? No, just use this formula. If you use this formula, you can easily get this result. So I think I will do one, no, and then you can do the next two, that is B and C. So let me to do the first one, that is cos theta equals 1 by 2, and we all know cos 2 theta equals, just put the value of cos theta. So here cos 2 theta equals, we all know that is how much, 2 cos square theta, 2 cos square theta minus, and here this is 2, and cos theta is 1 by 2 into a plus 1 by a, so we write how much, 1 by 2 into a plus 1 by a whole square, again the whole is whole square, because this is going to be 4, no. So how much can we write, we can write 2 into 1 by 4 into, and a plus 1 by a whole square, so it is going to be a square plus 2 into a into 1 by a plus 1 by a square, no. How it is obtained, just use the formula, that is a plus b whole square is a square plus 2ab plus b square, no. So we write this one. So here a and a is cancelled out, and what will be the result? So here a and a is cancelled out, so what will be the result here? You have any idea what is going to be the result? So what we can write here, so we can write 2 into 2 is going to be cancelled out, so it is here 2, no. So it is 1 by 2 into a square plus 1 by 2 into how much, 1 by 2 into 2 plus 1 by 2 into 1 by a square, no. So again here 2 and 2 is cancelled out. Oh, there is 1 also, minus 1, so minus 1, and here minus. So this one is this will give us 1, and this plus 1 and minus 1 is cancelled out, so let's write. So it is 1 by a square plus 1 by 2 a square plus 1 minus 1, and both is cancelled out, so the result will be 1 by 2 into a square plus 1 by a square. So it is RHS. In a similar way, we can prove all of these two, and just use the formula. As here it is given sine theta, and we have to prove this cos theta, so we will use this formula. And here sine beta is given, and we have to prove sine 3 beta. So we have the formula, sine 3 equals 3 sine a minus 4 sine q. So you can use this formula and prove this sine beta. If sine beta is 1 by 2 into k plus 1 by k, then we can easily prove that sine 3 beta is 1 by 2 into kq plus 1 by kq. Okay. Now, how you will prove this one? Cos 2a minus cos 2b whole square plus sine 2a plus sine 2b whole square equals 4 sine square a plus b. How you will prove? Do you have any idea? Here it is cos 2a. Cos 2a minus cos 2b whole square plus sine 2a sine 2b whole square. So I think just expand this one. Cos a minus b whole square, and sine a, suppose that I am reading it as 2 as a, so sine a plus sine b whole square. So just for a, what we will do, LHS here, LHS is, we are solving this one, and I will only solve this one, and using the same concept you can solve this one. So here it is cos 2a minus cos 2b whole square plus sine 2a plus sine 2b whole square. No? So how you will prove? Cos 2a minus cos 2b. And do you remember, can you think here that it is a minus b whole square? So just expand using the formula a minus b whole square. So it is going to be cos square 2a minus 2 cos a into cos b plus cos square 2b, and plus, then we will expand this one, that is sine square a, so sine square 2a plus 2 sine 2a, so 2 sine a into sine b plus sine square 2b. No? Okay. So after writing this much, what you will do? You can see here that cos square a, that is cos square 2a, and this sine square 2a. We have the formula cos square a plus sine square a is 1. So these two form 1. Again cos square 2b and sine square 2b, these all forms 1. So we will get 1 plus 1, that is 2. So 1 plus 1. These cos square 2a and cos square 2b forms 1. As we know, cos square a plus sine square a, cos square a plus sine square a is equal to 1. And using the same formula, you can observe here that here it is cos square 2a and this one is cos square 2b. So cos square a plus sine square a. So here it is cos square 2a and this one is sine square 2a. So cos square a plus sine square a is 1. And the next one cos square 2b. And this one is sine square 2b. Both have the same angle, 2b, 2b. So it will form 1. So 1 plus 1 is 2. And minus 2 into cos 2a plus cos 2a into cos 2b. So we write cos 2a into cos 2b plus how much? This one 2 sine a into sine 2b. 2 sine 2a into sine 2b. Okay, this one is 2 minus how much this one is going to be? Take common 2. So it is going to be cos a cos 2a cos 2a cos 2b. This one is minus sine 2a and this one is sine 2b. No? And we all know the formula for what will be what will the formula if there is given cos a cos b minus sine a sine b. So cos a cos b, cos a cos b minus sine a sine b. Here it is cos a cos b minus sine a sine b. So we can relate this one. So it is going to form cos a plus b, and here is the angle is 2a 2b. So we will write cos 2. So we write 2 into minus 2 into cos 2 into how much? A plus b. No? So it is 2 into cos 2a plus b. Just take the common 2. So while taking common 2, 1 minus cos 2 into a plus b, cos 2 into a plus b. Again you have to think one thing, that is 1 minus cos 2a. So we all know we have to prove this sine square, no? Sine. And here it is sine. So if there is cos 2a, the form, and we have to prove this sine square, so we will use this formula. And here you can relate that 1 minus cos 2a equals 2 sine square a, 2 sine square a. So here we have obtained 1 minus cos 2a, and here instead of a there is a plus b, no? So we can easily write 2 into here 2, no? So we write 2 into sine square a, no? A means a plus b, so we write a plus, and here 2 into 2 is 4, so we write 4 sine square a plus b. So we have also proved this RHS, no? Okay, so I have completed this first one, and using the same concept you can also complete this second. And if you find any difficulty while solving these problems, then you can comment us in the comment section, or you can also directly inbox us on our Facebook page, no? Then we will try to reply your queries as far as possible, as soon as possible. Okay, so the next thing is that And not only this much, if you find any kinds of difficulties related to this multiple angle of 2a and 3a, try to contact us on Facebook as well as on comment section, and we will try to solve this problem as soon as possible.